Have you ever wondered if we are alone in the universe, or if there's life beyond Earth? It's a question that has fascinated humans for centuries, sparking countless debates, theories, and explorations. Yet, despite our best efforts, the answer remains elusive. In our quest to find extraterrestrial life, we look to the stars and beyond, to the vast expanse of the universe. And right there, within our own solar system, we find intriguing possibilities. Imagine a world not too dissimilar from our own, a moon orbiting the gas giant Jupiter, known as Europa. Europa, smaller than Earth's moon yet teeming with potential. Beneath its icy surface, scientists believe lies a salty global ocean, and most importantly, this celestial body generates its own oxygen. Yes, you heard it right, oxygen, the life-giving gas that we breathe here on Earth. This brings us to the fascinating moon of Jupiter, Europa, a celestial body that could potentially sustain life. So, how does this icy moon of Jupiter generate oxygen, you ask? Well, it's a fascinating interplay of radiation, ice, and the forces of nature at work. It all starts with Jupiter's magnetic field. This might seem like a bit of a jump, but bear with me, it's all connected. Jupiter, being the largest planet in our solar system, has a very strong magnetic field. This field is constantly bombarding Europa, Jupiter's icy moon, with high levels of radiation. Now, Europa's surface is covered in water ice. When this ice gets hit with the radiation from Jupiter's magnetic field, an interesting chemical reaction occurs. This radiation splits the water ice into two separate elements, hydrogen and oxygen. This process is known as radiolysis, and it's the first step in Europa's oxygen generation. But we're not done yet. Next comes a process called sublimation. This is where the hydrogen, being a lighter element, escapes into space. This leaves the oxygen behind on Europa's surface. And it's not just a small amount of oxygen. We're talking a considerable amount that could, theoretically, support life. Now, this doesn't mean that there's a lush, oxygen-rich atmosphere on Europa. Far from it. The oxygen is locked in the ice on the surface. It's not freely available in the atmosphere like it is on Earth. But the fact that it's there, and in such quantities, is absolutely fascinating. Throughout this process, Europa's surface is continually being replenished with fresh water ice from its subsurface ocean. This means the process of radiolysis and sublimation can continue indefinitely, constantly generating more oxygen. It's a fascinating natural process, isn't it? But what does it mean in terms of numbers? Let's delve into the quantity of oxygen produced on Europa. This icy satellite of Jupiter is a potent oxygen factory, its surface bombarded by solar radiation, breaking water ice into hydrogen and oxygen. The lighter hydrogen floats into space, while the denser oxygen lingers, creating an atmosphere thin but rich in oxygen. Here's a stunning fact. According to NASA, the oxygen levels on Europa could sustain 1 million people for a full day. That's right, 1 million people could breathe on a moon over 390 million miles away from Earth. This discovery isn't just about hypothetical space colonies, though. It's a beacon in our ongoing search for extraterrestrial life. If an environment as harsh and remote as Europa can sustain such levels of life-giving oxygen, it broadens our horizons in the quest for life beyond Earth. So, Europa's oxygen generation could potentially breathe life into our quest for extraterrestrial beings. So, what does the future hold for our exploration of Europa? A truly tantalizing question, isn't it? NASA's upcoming Europa Clipper mission is set to launch in the late 2020s, and it's brimming with potential. This mission aims to conduct detailed reconnaissance of Europa's icy surface and investigate whether the icy moon could harbor conditions suitable for life. The importance of these missions cannot be overstated. They hold the key to unravel the mysteries of life beyond our planet. By exploring Europa, we are not just probing a distant moon of Jupiter, we are pushing the boundaries of our understanding about life itself. How does it form? Can it exist in environments vastly different from our own? And remember, Europa is just one moon, in one solar system, in one galaxy of countless galaxies. As we continue to explore the mysteries of the cosmos, who knows what other surprises await us in our cosmic backyard?